water year 2025 and talk about what the expectation was versus the reality. So here's a summary of water year 2025. The figure shows what the snowpack was looking like compared to average conditions, average being 91 through 2020. And you can see from this figure that conditions were better the northern you were on the basin. The further south you moved, the worse conditions looked. And in the south, they looked pretty bad. I'll talk about this. So the spring, we had very dry conditions, some of the driest on record, and that tanked the water supply forecast. The summer continued to be dry. We had wildfires throughout the basin here in Colorado, and within our district, one of the largest fires, the Lee Fire. In the fall, we got some precipitation. We had some monsoons later in the season, and that did help things out. So let's focus in the river district's boundaries. So this is a similar figure. So the numbers here show 2025 compared to 1991 to 2020 average. You're seeing snow water equivalent, and this is on April 2nd, which was when snow generally peaked in Colorado. That peak happened 10 days earlier than usual, and if you look within our district, you see that, yes, we still have this trend north to south. Things were below average, but they weren't terribly below average, right? You're seeing high 70s to 90-ish% of average. So, all right, we talked about snow. Now let's look into water supply forecasts. So this is stream forecast, 50% exceedance probability. The numbers here are the forecasts for each of the basins you're looking at for 2025, also compared to average, so 91 to 2020. These numbers are what was forecasted by the NRCS on April 1st. And you can see that these numbers look pretty similar to what we were seeing during peak SWE, right? So in our district, high 70s and in the 90s of projected forecasts. The little dots you see on this map are snowtail sites. And I just wanted to point out that the Grand Mesa, the orange dots between the Colorado and the Gunnison, really did not do well in 25. So fast forwarding to June, water supply forecasts looked completely different. And if you were expecting the conditions you thought would maybe happen based in the April forecast, reality was very different. So here's a similar graph than before. Yampa White reduced from over 90% of average of prediction of what the stream flow was going to be to 48. On the Colorado headwaters, that dropped from over 90 to 72. In the Gunnison Basin, from high 70s to 52. And I would like to see a show of hands. Who in this room looks at stream flow forecasts throughout the year? All right, quite a number of you. And who uses these forecasts for some type of decision-making around water operations, channel, reservoir, users, on the ground, producers, right? And I know from the River District, we also operate reservoirs, and it was a challenge this year. And yes, forecasts aren't perfect. No one can predict the future. It is a great tool. It's the best tool we have. But this year, with a really dry spring, it was very challenging. So this is a graph that the Colorado Climate Center produces. It plots each year on precipitation on the x-axis and temperature on the y-axis. So the further you move to the right, it's wetter, and the further up you go, it's drier. And the quadrant on the top left is hot, dry conditions. And 2025 fell within this quadrant. We had the 7th warmest year and the 9th driest year. And I should emphasize that this graph is for the Colorado drainage within the state of Colorado, so western slope. For comparison, 2025 was similar to 2012, if you remember that. It was also similar to 2021. And 2002 was the driest year we've had on record. 2018 was the hottest year we've had on record. And I really like this graph, also by the Climate Center. This is showing precipitation in the state of Colorado, December through July. The reason why they're cutting off October, November was that October and November was not bad. We got decent snow. But starting in December, things started to look dry. So the browner colors are drier conditions. This is precipitation. And the greener colors are wetter. And you can see this very clear divide between the west side of the state and the Front Range. Here on the west, we had record or near record. You can see the dark brown on this figure is record dryness. And if we're looking just at these months, we had the 11th driest on record for the whole state. So to look at the basin as a whole and what happened throughout the year, this is precipitation accumulation for 2025. Blue colors are wetter than average, red colors are drier than average. So this is what October and November looked like. We have quite a bit of blue on this map, but when we start moving through time, this is what we get. Things just started to dry out and they never came back from these dry conditions. So that's what we had for 2025. And if we're trying to look into the future, a positive note is that the soil moisture currently is not terrible. Here within our district, conditions are average or above average, so the precipitation we got recently has helped out conditions, and it's a good thing moving into the winter and starting from at least a somewhat positive place. So if we look at the temperature outlook, October, November, and December, the blue box is the state of Colorado. And what the forecast is showing is that we'll have above average temperatures, so warmer than normal for October, November, December. If we look further into the future, January, February, March, equal chances, which maybe is a good thing looking into the winter, but it's also really hard to tell. If we look at precipitation, we are looking at drier conditions, October, November, December for the state of Colorado. And further into the future, also equal chances. So for the next 3 months, the forecast says warmer and drier. But into the future, could be different. All right, let's look now at the basin at large. For context, here on this map, the blue shaded area on the top right is the Colorado River District's boundaries when we look at the basin, the whole basin. And I'll be focusing on Lake Powell and forecasts of inflows into Lake Powell, the largest bucket of water here in the upper basin. Just as a refresher, similar to the first slide, this is what peak snow looks like for the basin at large. And so you can see up top, we were ish average snow. At the bottom, things looked very bad, really worse conditions, I would say, in some of these basins. All right, so we talked about forecasts within the River District area and how that changed from April to June, right? That big drop in what the stream flow forecast was. This is forecasts for inflow into Powell produced by the Colorado Basin River Forecast Center. And on the y-axis, you have 1,000 acre feet. This is for January. So in January and I should emphasize that this is the 50th percent exceedance. The forecast produced several probabilities. This is the middle of it. In January, the forecast was for over 5 million acre feet, April through July, inflow into Powell. April, that dropped to 4.3 million acre feet into Powell. June, that dropped to 2.9. So a little over 50% of what the expectation was when we were looking in January. And what was observed was even lower. It was 2.6 million acre feet. And I'll show you in the next slide. This is January forecasts versus observed for the last 10 years. And yes, every year is very different. 2025, that's what we saw. Forecast in January, which is relatively early compared to the observed, which was basically half of that. We've seen other years where we've had these similar conditions. In 2018, 2020, 21, 22, those were also years where the forecast in January was higher than what was observed. But we've also seen the opposite. 2019 is maybe the exact opposite version of this, which is the forecast was half of what was actually observed. And 23, we also had a similar trend. And right, I want to reemphasize, this is 50th percent exceedance probability. The forecasts have 10 to 90% exceedance probability because it is very hard to predict the future. Well, I would say it's impossible to predict the future, and these forecasts do the best that they can. And when the spring gives us conditions that are very different from average, it becomes really hard. And that's when these forecasts tend to be very different from what is observed. So to step back and talk a bit about how snow becomes stream flow and what are all of the components that play a part in this story, right? We have snow that falls on our lands, but we have temperature. Temperature plays a role in determining if precipitation is going to fall as snow or if it's going to fall as water. It also plays a role into how fast snow is going to melt, how thirsty the atmosphere is going to be. We have sublimation, which is snow being lost directly to the atmosphere, so the snow becoming water vapor. We have soil moisture, which is sucking part of this snow melt. We have groundwater that definitely contributes to river flows. We have dust on snow events. And those are definitely very hard to predict, but they change how fast the snow is melting. We have rain on snow events that also change how the snow is melting. And we have spring and summer precipitation, which affect how much the flows are going to be. This is not simple. It's not a simple puzzle. As I said before, it's basically impossible to predict 4 months in advance what things are going to do. But there's definitely an opportunity to measure some of these boxes better, right? We can do a better job at understanding what the snowpack looks like. We can do a better job at understanding what soil moisture is looking like, and groundwater, in some of these boxes. But as we're seeing hotter, drier conditions and temperature is going up, that is impacting how much precipitation is falling as snow. It is also changing how snow is melting. And so research shows that snow is not going to be as a significant determinant, I guess, of flows as it once was. The other boxes are playing a bigger role in this puzzle. So on that note, I did want to show you this image because airborne snow observatories flies planes in basins within our district to measure the snowpack. It's a snapshot in time, but it measures snowpack in a watershed the time of the flight. And this is an image of the Taylor River Basin, And in the Upper Gunnison, the Taylor and the East River, these flights have occurred since 2018. And 2025 was the first year that the Colorado River Basin Forecast Center incorporated this data into their models. And it's a big thing. And why they were able to do that is because they had a number of years of data. They felt like incorporating this would produce a better forecast. So I think this is a really good news. And okay, so now that's it for the good news. You have seen this graphic before in different ways, I'm sure. This is Lake Mead and Lake Powell's storage stacked on top of each other. On the left is million acre feet, so storage volume. And starting in 2000, we saw these reservoirs lose storage year after year. Yes, there are some years where things get better, and 2023 was a year like that, because we reached these extreme crises in 22, beginning of 23, where Powell dropped to 35.21. And that is a pretty critical level. 23, we were lucky, but we're basically back to the same place we were in 22. This is where we're currently at. Lake Powell is 29% full. It's at elevation 35, 45. Lake Mead, right, they're operated in conjunction, so Lake Mead looks somewhat similar. And you can see the status of the other initial units here, Flaming Gorge, Blue Mesa, and Navajo. They're definitely smaller buckets. They're doing better. But this problem with Lake Mead's elevation dropping is a real problem, and this diagram, I think, is really helpful. This shows Glen Canyon Dam, and Glen Canyon is what forms Lake Powell, right? These two tunnels on Glen Canyon Dam are how water can be released. So you have the darker blue tunnel, which is water. It can be released to produce power. And that happens above elevation 3490. If the reservoir drops below 3490, you cannot use these dark blue tunnels to release water out of Powell. You can use the light blue tunnels, but the light blue tunnels were not designed or built to operate long-term, and there's a lot of problems with these light blue tunnels. And because of that, the Bureau of Reclamation is trying to protect elevation 3525. That provides a 35-foot buffer to protect this minimum power elevation of 3490. More recently, there is a new elevation here to be considered, which is 3,500, that is 10 feet above the 3490. This elevation is linked to supplemental environmental impact statement that was developed for the near-term operations of Powell and Mead, so 2023 to 2026. And this document says that to protect elevation 3,500, the releases out of Powell can be reduced and get to a minimum of 6 million acre feet. Okay, the elevation 3525, I should say, is linked to drought response operations agreement. And that's the trigger that can impact the release curve out of Powell. It can also trigger releases out of the reservoirs in the upper basin. So a few years ago, when we had releases from Blue Mesa to prop Powell up, that was because of this 3525 elevation trigger. So 24-month study that is put out by the Bureau that looks at Lake Powell for the next 24 months and how things could look like, right? There are 3 lines on this map. I should say the vertical black line is end of August conditions, because this was the 24-month study from September. So end of August, you can see what the elevation and the storage was here. And the April through July inflow, I've talked about this before, was 2.6 million acre feet, 41% of average. Water year 2025 inflows, 4.7 million acre feet, 48% of average, and the set release this year for Powell was 7.48 million acre feet. So yes, 2025, we continued to drain Lake Powell. The set release for 2026 is also 7.48, but as I mentioned before, this 3,500 feet trigger could reduce the releases out of Powell in 2026. Time will tell. All right, so back to the graph. We have 3 lines here that are 3 different scenarios. The top one is maximum inflow into Powell. You could ignore that one, because when have we seen that happen? I don't know. Then we have the green one that is the most probable. And in the recent past, that curve also has not, we haven't really seen that curve. The red one is minimum probable, and that's in the more recent hydrology, more of the conditions we have seen. The problem with what we're seeing for the next 24 months is we're seeing all of these elevations being triggered. 3525, we're dropping below that potentially, right? We're dropping below 3,500 potentially August of next year, and we're reaching minimum power pool as well, and dropping below it potentially. And to make this graphic even more gloomy, I will show you this. End of August 2025 conditions, elevation 3548, equivalent to basically 7 million acre feet of storage into Powell. The problem is that this 7 million acre foot includes water below minimum power pool and dead pool. You can't really use that water. And there was a recent paper that dived into this recently that I think is worth emphasizing. If we see 3,500 feet as the elevation, if water is above that, we can use it. If water is below that, we cannot use it. The actual usable storage in Lake Powell, end of August, is not 7, it's 2.7. 4.3 is not usable water. And so on that gloomy note, I will thank you. And I will welcome Andy Mueller, our general manager, and he can talk to all of us about how we solve these problems and what the future can look like. So thank you.